Mr. Wolfsberg, thank you for joining us for this interview. First, I'd like to ask you, I've read your bio, and I'd want to ask you, what other areas did you think you would go into when you were a high school student?
Instead of hydrology, which I did go into.
Yes.
I thought I was going to go into chemical engineering.
Well...
That seemed to be what I liked chemistry, so I assumed chemical engineering might be kind of exciting.
So what changed your course?
Okay, so when I was a junior in high school, I received a letter in the mail that said, come to the University of Arizona, study hydrology, get in-state tuition.
Yeah, and I read on how you had some of the greatest people in hydrology at the time all there.
Correct.
Yeah. How was that feeling being at the nucleus of innovation in that field while you were learning it?
While I was there?
Yeah.
Totally intimidated. It didn't dawn on me. It didn't dawn on me how significant these professors were until about my junior or senior year of college. I mean, I knew they were the big names in the field, but I was just struggling to make sure I was learning what they were trying to teach me and just kind of get into the mode of succeeding in college. Then it kind of started dawning on me that these were the guys who sort of invented modern hydrology and wrote the textbooks and mapped out the path that a lot of people like me now get to take.
That's pretty crazy. All right. So also, I'd like to know. So, what do you think was the biggest turning point in your life that got you here, besides University of Arizona? What got you into science? What got you thinking, I'm going to be a scientist?
That's kind of a loaded question because I grew up here in Los Alamos, and I didn't really know that there was much else to do, and so it just sort of seemed like I should go into science. I don't think I actually fell in love with science, though, until well into my undergraduate study when I started seeing how exciting it was. But I'll be honest with you, nothing ever jumped out at me like, hey, I think I might want to be a lawyer or a doctor or a politician. Those things, I didn't seem to have a knack for that, and they never really appealed to me. So I kind of followed a beaten path, but sort of forged it as I went along as well.
Okay, that's awesome. So your presentation talks about how energy and water are all tied together and how we need both to survive, and we don't understand the connection yet. What is the most interesting connection you can point between energy and water that would blow our audience's mind?
I think there's two really big pieces. Well, maybe can I give you three?
Yeah.
Okay. So one, with water, you're going to see tonight in my talk, agriculture uses a lot of water, but we need that. We need food. We need to grow food, and so the use of water in agriculture is sort of a given. We can think about how to conserve, but once we take away all the water we put into agriculture, there's a limited supply left for everything else we need to do. It takes water to cool a power plant that makes the electricity that then lights our houses. It takes water to extract gas and oil, which we need to heat our homes and drive our cars. So what I think, and what I hope, kind of one of the messages that I hope the students get tonight is there's this amazing dependence on water to make the energy, to extract the fuels that we need for energy, and to try to find ways to use less water is really the challenge for your generation. And the other piece of this is water takes a lot of energy. To treat the water for us to drink, to move the water to where we are from where we pump it out of the ground to where it comes out of the lakes, takes a ton of energy. And you'll hear a little bit about how much energy states like California use. And so a lot of energy required for water, a lot of water for our fundamental energy. Finding that the good balance in there is really the challenge we're at, and we do not have that solution.
So, have you done a lot of research into water infrastructure projects like NWAPA, I would think, where we would build a bunch of dams on the Canadian rivers and it'd be a joint U.S.-Canadian project. We just funnel all that water. Excuse me. Do you have any what is your Band-Aid or solution, or do you not have one and you're just preaching, or do you not have a totally hammered down solution to this problem?
I think it's a multi-spectrum solution. There's a lot of things we need to do. We need to use less fresh water when we don't need it. One of the things I'll talk about tonight is how to use non-traditional water to extract oil and gas. There's something called brackish groundwater, very saline. You can't drink it. We're not using it to any beneficial use at this point. If we go and start utilizing brackish water for extracting oil and gas, then we save our fresh water for more important economic benefits. We need new technology. We need to figure out how to cool our power plants with less water. Hybrid cooling, water and air, or even new technology for better efficient air cooling would conserve tons of water. So to me, it's not so much that there's a absolute amazing new widget out there, but there's a lot of new technology and there's a lot of planning and infrastructure that are going to get us to the solutions. And I focus a lot on the Southwest, so you have a different set of problems in different regions of the country, like along the Canadian border, like you mentioned.
All right, awesome. So if I remember, so how would you fix the problem with us using water and power plants? Because if I remember from middle school or something, right, is that all the power we get is basically just we heat up water, we generate it into steam, and we push it into a turbine, and that spins that turbine and creates an electric current. Do you have any ideas on how we could either change that process, or is that an unnecessary linchpin, but we can find many other ways to save water?
I think you answered it. It is a necessary linchpin now. Much of our electricity is created, as you mentioned, thermoelectric power production. There's got to be new technologies. Pushing fluids through very, very small pores and creating electric currents is one idea that people are pushing. More renewable energy is another. So, it's not in the immediate future that we're going to be moving away from thermoelectric power plants that require some kind of cooling, for which water is the fundamental cooling fluid right now. But looking to new technology, and I challenge you and your colleagues to go out and figure this out, but also bringing in a better mix. Where there's wind, can we use wind? Can you guys figure out how to store the energy so we can use the wind and the solar? Because creating electricity when we don't need it has limited use, right? Mm-hmm. So I hate to sound like it's a multi-solution to one big problem, but there's a lot of pieces to it, and there's not going to be one single Band-Aid.
That's true. So what do you think is the easiest Band-Aid our audience could do right now that would do the greatest amount of good?
Conservation.
Like the biggest part of conservation, like
use less water, which means use less electricity. Figure out how to grow crops with less water, more efficient crop growth, and use less water to extract oil and gas. And researchers at the lab in my organization are looking at how to use other fluids, supercritical carbon dioxide, explosives, things of that nature. So we use less water, conserve the water, and save it for something else.
All right, that's awesome. So if there's one thing you would want to just say right now in a message that could be held on for the rest of this interview, or one thing you would like to leave in the audience's minds, what would it be?
Water and energy are intricately related to each other. Can't do one without the other. We've now reached a time when use and requirements and demand for both water and energy are going up, and the availability is either the same or potentially even going down. So we have a lot more demand for both water and energy, and there's a limited resource there. So status quo is going to be a very, very difficult position to maintain as we move to a larger population, especially globally, but here in the United States, and to maintain our economic growth that requires energy, and generally inexpensive energy. So understanding that we have to change and we have to start solving these problems instead of just assuming that water is a free commodity that is always there for us to produce electricity with and everything else, is a mindset that we need to get out of. And hopefully, I'm thinking about it. I hope you guys start thinking about it a lot, because this will affect you.
All right, awesome. Thank you very much for your time.
Thank you. It's a pleasure.